Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Domain 5.0 of the Core 1 exam centers on troubleshooting, a critical skill area for support technicians. This domain emphasizes a structured approach to identifying and resolving issues related to hardware, software, networks, and peripherals. It covers a wide range of devices, including desktop computers, laptops, mobile platforms, printers, and connected components. Technicians must be prepared to diagnose symptoms, apply logical processes, and restore functionality efficiently. The A+ certification validates the ability to follow troubleshooting procedures consistently in both predictable and dynamic technical environments. Structured troubleshooting is important because it prevents random guessing and reduces wasted time. By using a consistent process, technicians can approach issues methodically and increase the chances of identifying the root cause without introducing new problems. A structured method also ensures that each step is documented, supporting communication and accountability. When multiple issues are present or when time is limited, having a standard approach helps streamline efforts and ensures no important details are overlooked. The 6-step troubleshooting methodology outlined in the CompTIA exam serves as a foundational framework for problem solving. These steps are: identify the problem, establish a theory of probable cause, test the theory, establish a plan of action, verify full system functionality, and document the findings. This process is designed to ensure that technicians address not only the immediate symptom, but also prevent recurrence. Understanding each phase is essential for answering scenario-based questions and for applying best practices in real-world support situations. Troubleshooting in this domain includes a broad range of issue types. These can involve hardware problems such as boot failures, unexpected shutdowns, overheating, or peripheral connectivity failures. Display issues, like flickering screens or no video output, also fall within this scope. Network slowdowns, dropped connections, and IP configuration problems are addressed, as are printer jams, driver errors, and wireless connectivity problems on mobile devices. Familiarity with these categories helps technicians triage effectively and select appropriate tools and strategies. Differentiating between symptoms and root causes is key to successful troubleshooting. A symptom is what the user experiences, such as sluggish performance or a blue screen error. The root cause may lie much deeper, possibly due to faulty RAM, an outdated driver, or malware infection. Technicians must avoid treating only the symptom, as this often leads to repeat problems. Diagnosis involves drilling down through observed behavior to find the technical reason behind it, which then informs the correct solution path. User input is often the starting point for identifying an issue, making effective communication with end users an important aspect of troubleshooting. Users provide the initial report and can describe what they were doing when the problem occurred, what they saw or heard, and whether the issue is ongoing or intermittent. Asking clarifying questions helps uncover relevant clues, such as recent changes to the system or signs that indicate a failing component. Before making any changes, it is vital to document these observations and any actions already taken by the user. Documentation is a necessary part of the troubleshooting process and supports both resolution tracking and future problem solving. By recording each step, including tests performed, changes made, and results observed, technicians create a knowledge base that can assist others and prevent repeated investigation of the same issue. Documentation is especially important in formal support environments where service-level agreements or audits may apply. It also provides a trail of accountability when handing off to another technician or escalating the issue. Escalation is the process of transferring an unresolved issue to a higher level of support or a subject matter expert. This step is taken when all standard troubleshooting actions have been exhausted, or when the problem falls outside the scope of the technician's authority. Successful escalation requires detailed notes on what has already been done, including failed attempts and current system behavior. This avoids redundant troubleshooting and enables the next technician to pick up seamlessly and continue toward resolution. Diagnostic tools and built-in utilities play a major role in system troubleshooting. Software utilities like Device Manager can reveal driver problems or disconnected hardware. Task Manager shows current resource usage, highlighting processes that may be consuming excessive CPU or memory. Event Viewer logs system events and errors, offering insight into failure patterns. On the hardware side, tools like multimeters can test power supply outputs, while cable testers help verify network or peripheral connections. These tools provide objective data that supports faster and more accurate diagnosis. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Working safely during troubleshooting is essential for protecting both the technician and the equipment. Before beginning any work, systems should be powered down and unplugged unless the task specifically requires a live environment. Electrostatic discharge precautions, such as using wrist straps or anti-static mats, help prevent component damage. Technicians should also avoid working near moving parts, like cooling fans and hard drives when powered. And personal protective equipment may be necessary in environments with dust, heat, or potential hazards. Safety procedures are not optional. They are an integral part of responsible support practices. Communication skills are just as critical as technical ability when supporting users. Technicians must remain calm and professional, even when dealing with frustrated or confused individuals. Active listening allows the technician to fully understand the problem and avoid missteps. Using clear, jargon-free language helps users follow along and stay informed. It's also important to set realistic expectations for timelines and outcomes, especially when the issue is complex or requires escalation. Strong communication improves user trust and contributes to smoother resolution. Intermittent issues can be particularly difficult to diagnose because they do not always occur predictably. Problems such as flickering screens, sudden reboots, or dropped network connections may be caused by loose cables, overheating components, or degrading power supplies. Because these symptoms come and go, they require careful observation and timing to isolate. Technicians may need to simulate specific conditions or leave monitoring tools running over time to catch the issue in action. Intermittent issues test both patience and methodical thinking. The A+ exam expects technicians to apply troubleshooting techniques in a structured, logical way. Exam objectives include recognizing symptoms, selecting the correct next step in the process, and avoiding shortcuts that may skip necessary stages. You may encounter questions that present multiple valid-sounding answers, but only one fits the structured methodology. Familiarity with the 6-step process helps clarify which answer is appropriate and reinforces consistent problem-solving in real support scenarios. In real-world environments, it is common to encounter systems with multiple issues at once. Effective troubleshooting requires prioritization, deciding which issue to address first based on urgency, business impact, or ease of resolution. For example, a power failure that prevents system use should take precedence over a misaligned printer. Technicians must learn to triage their workload, starting with the most disruptive or time-sensitive problems. This approach ensures efficient use of time and delivers maximum value to the user or organization. Baseline behavior refers to the expected, healthy performance of a system or environment. Understanding what normal looks like helps technicians identify when something is wrong. If a user reports slowness but resource usage is consistent with baseline behavior, the issue may lie elsewhere or be a perception mismatch. When baseline data is available, it becomes easier to confirm problems and guide the investigation toward deviations in performance, configuration, or hardware behavior. Ticketing systems and workflow management tools play a critical role in structured troubleshooting environments. Each support request is logged as a ticket, which includes user information, reported symptoms, progress notes, and final resolution. These systems support accountability, time tracking, and performance metrics for support teams. They also enable efficient escalation and ensure that nothing is overlooked or forgotten. For organizations with formal support processes, ticketing is a mandatory component of troubleshooting. Environmental conditions can also cause or contribute to system issues. Excessive heat may cause systems to shut down or throttle performance. High humidity can lead to corrosion or condensation damage, while dust buildup can block airflow and cause overheating. Devices located in industrial or unclean areas may require regular maintenance, such as filter cleaning or component inspection. Identifying and addressing environmental risks helps extend hardware lifespan and reduce the frequency of service calls. Technicians must also know when to repair a system versus replacing it. This decision is based on several factors, including the age of the device, the cost of replacement parts, the time needed for repair, and the likelihood of future failures. If a part is obsolete or expensive, replacement may be the more economical and reliable solution. Downtime considerations, user expectations, and risk tolerance also influence this decision. It is important to document the justification for any replacement, especially in managed environments. To summarize, Domain 5.0 of the Core 1 exam establishes the foundation for all troubleshooting practices. It emphasizes a structured, repeatable approach to diagnosing and resolving technical problems across a wide range of devices and systems. From identifying symptoms and isolating root causes to using diagnostic tools and escalating issues appropriately, this domain prepares technicians to handle challenges with professionalism and clarity. Later episodes will build on this foundation by exploring specific categories of issues in greater depth. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.